Great. All right, Steve from Rescue. I would like to thank Steve for his generous and enthusiastic help getting this started. And
quiet, please.
And would you please raise your hands if you've used ZFS before? Okay, so a third of you possibly. And how many of you are using it in production? Okay. And how many of you are using any kind of volume management, not just like simple partitioning for what you're doing? Okay. Are you guys using LVM? LVM? Okay. You guys know how different LVM and ZFS are? Okay. All right. Okay. These are all hopefully going to be answered. ZFS is a volume manager. It also manages RAID. It also does things that LVM doesn't do, and that's the next slide. But by default, your volume management on ZFS is flexible. So you start off with your 10 terabytes or whatever you have, and you create file systems on it, and they all say 10 terabytes free because that's how many blocks you have. And if you want to cap the size of something so it doesn't take over your whole pool, you can do that. But otherwise, whoever fills up first fills up first. So very flexible on its sizing there. It's a file system. It has attributes. There's lots of extended attributes. There's a whole hierarchy of things, and lots of clever things can be done with the ZFS attribute system. People manage jails, for instance, in BSD, heavily through setting ZFS properties. It integrates memory cache, intent logging, level 1, level 2 caches. Level 1 cache is always going to be in RAM. Level 2 cache is, you can set that to be a or any number of SSDs you'd like. It has built-in data compression. It's not the tightest data compression, nor should it be. What it is, it's consistent time data compression. If it doesn't compress within the first 13 megs or something like that, I don't remember the actual detail on it, it just gives up and writes it plain. So you're not gonna waste a lot of time compressing stuff because the compression rate is something like 4 gigabits a second or something like that. So. And something else that is particularly unique to ZFS is that it can do block level streaming, so you can replicate your file system snapshots. Now this is not like DRBD. Do you guys know what DRBD is? Raise your hand if you do. I can't see you shake your heads. Okay, so DRBD is a network block replication system. It's a way you can have 2 RAIDs mirrored over Ethernet. That's been in Linux for centuries. And this is similar, but it's not live. It's not a live streaming, whereas DRBD is a live streaming replication. What you do is you say, I have a volume, it has snapshots, I'm going to send A, B, and C snapshots over to that other pool, and it'll just recreate it, and it's so handy for backups because it's only sending the changed blocks. So you don't have to do a full system file scan or read all the metadata of all the files and do all the MD5 hash sums to find the one file that changed, like you do with rsync. Growing your storage is an often asked question. ZFS really does want you to plan out how you're going to grow, because it wants you to have redundant storage. You add one disk to it, it's going to stripe across it. If you just add another disk, you assign it as it becomes a VDEV. If you add two disks, you mirror them, you stripe across the mirror before, and the new mirror. You have a RAID 5 or RAID 6 set. You can add another RAID 5, RAID 6 on it. Or if you just add one disk, suddenly you have a RAID 5 volume striped across to a one disk. So this is one of the gotchas that people sometimes don't like about ZFS. If they haven't planned to how they're going to grow their storage, they can end up having to recreate their storage because they add one drive and now you can't remove it. So there's you have to take care. But if you're interested in as redundant as it gets, it wants to be redundant, so it'll help you out. Here's a command that you create a ZFS pool with, and there's multiple ways to do it. Clearly, there's never one way to do anything. Your zpool create command, you're going to use a -O option, and that A shift option gives you 4096 byte sectors. Gives you access instead of like because lots of disks report 512, and you don't really want that. And then the first example here, we can do a RAID Z1, which is ZFS term for RAID 5. And actually, that example is wrong. I don't want to mix a RAID Z1 and RAID Z2. That was silly of me. But here, you define your volume first, and you add your members, the volume, to it. And so here you have a stripe across two RAID Z1 sets. The middle example is a set of 3 mirrors that'll be striped across. And the bottom one is going to be one volume that is going to be RAID 6. So we can entertain lots of questions, and I'm actually about halfway through my slides, so there will be plenty of time for questions. But when you're creating ZFS, you have to be very cognizant of how UDEV works. You can guess that you're always going to have an SDA and an SDB, but that's not necessarily guaranteed, especially if you go into your case and you reorder the cables on your drives, or you reorder your drive ordering in the bays, or it boots up with an update and it says, "Oh, hey, I'm going to enumerate the PCI bus backwards today." That doesn't help. It won't kill your ZFS, but what is more stable is to actually do the drive serial number. So this bottom example here shows you create a mirror and you give it the serial number names. You don't have to put /dev, /disk, /byid in front of it, because it'll just figure that out. But this is not only useful for creating stable way to bring up the volumes, also a great way to find which one failed. Okay, raise your hand if you've had to find a drive by serial number in your chassis. Oh yeah, It makes you want to get out your reading glasses, doesn't it? Because those things can be very small. But it's also one of those things, you're going to set up all those terabytes. You probably want to have a written list of where the drive is in the chassis. But there's also ways that you can like flash a RAID controller not RAID controller, HBA, and that's the next slide, so that you can help find stuff like that. So L2ARC, that's your layer 2 cache. That's block-based cache on presumably SSD. and it can be pretty useful. It might not be useful if you are running an entire volume set based on SSD to begin with. Then that would be completely redundant. I mean, that would be pointless, because you'd just be wearing out your L2 ARC for something that performs faster than it. Unless you wanted to do something like a PCI SSD, something that gets like 1.2 gigabits throughput. Who has one of those? You do? Oh, jealous. Streaming. So, when you're doing large writes, you don't use your ZIL, your intent log. But when you're doing random writes, you do use your intent log. Your intent log is a bit of fast storage you add, and it doesn't have to be large. You could have like a 30 gigabyte, like little tiny MSATA SSD or something, because you're probably never going to fill it. And it allows you to do your random writes and then write them reordered, so you get contiguous file streaming when it finally hits your spinning disks. So it's a great way to speed up multi process small writes. And I think LVM has something like that now, but I haven't gone through that how-to, so I cannot compare the two techniques in detail. So, and you can add them and remove them after the fact. So you can add cache with add pool name cache, add your log device, add pool name log, and stuff. You can mirror them. It's the same syntax as creating ZFS pool, or cache. You probably just want to stripe it so you don't add your RAID Z or your mirrors keywords in there. Now, why don't you like RAID controllers? Story? Anyone have a story about a failed RAID controller? Let me search in my pockets here. I've got a bunch. Yeah. You are totally hidden behind a RAID controller unless you really know like your LSI utilities for Linux, and they're not well supported and they're not well documented. And so buying HBAs, which are you might call SAS expanders or something like that, so the kernel has direct access to each disk, is how it helps do it. Assess health, assess bad blocks, and do its checksumming. So that's when you're building it, you don't need RAID controllers, or you put them in JBOD mode if you have them. So snapshotting is fun, right? Do you remember when LVM could only support 256 snapshots? Well, I recently almost killed one of my workstations. I ran it out of disk because I made some 60, 70 or so thousand snapshots in my pool. And I was really curious why, when I try and list all the snapshots, it wasn't stopping. But it didn't kill it. It takes a while to delete them. Rolling back, really simple syntax. You notice that the syntax doesn't begin with a slash when you're saying you give it the pool name, and you give it a volume name, and then you give it a snapshot name, and the snapshot name is the file system name with an @ symbol, and the snapshot name in this case is installed. And I don't know how it could be simpler. So clearly, I like it. So backing up is pretty simple. You start getting a lot of syntax that I'm not going to go through for the sake of brevity, but you can send separate collections of snapshots at a time. You can send the entire file system at a time, or you could send the last one, and there's like all those combinations. There's lots of little minus switches to help it send exactly what you want. I'll put you all to sleep if I go through those. But in this case, this example shows how you pipe it into SSH, and you can turn on compression, which might be useful. And then just do a ZFS receive, and then the receiving pool name. And I think it's pretty handy, and it's helped me do a lot of backups. The things you want to install after you get your pool going is, I would suggest ZFS Auto Snapshot and ZXfer. ZFS Auto Snapshot is yes, that guy. Yes. The font of ZFS knowledge, besides many people, it's a cron job and a really good bash script, and it uses the ZFS properties in the file system, and that's how you tune your snapshots. So if you want to turn off 15-minute snapshots or create a different snapshot periodicity, you want to set that through your ZFS get and set commands. A ZXfer is an automated, or a somewhat automated way to send those snapshots to a backup machine or restore from. It works both ways. It makes this, snapshot sending a lot simpler once you figure out its little minus tags, and it has a couple minus tags. And there's plenty of reading. Start at ZFS Linux org. Go to OpenZFS.org if you want more details. And Michael W. Lucas has written books on it with Alan Jude. Some of you have met them. They are nice people. So we can turn on the lights, and let's entertain some questions. Yes?
So I don't really have a lot of ZFS experience or even much knowledge about it, so I apologize in advance. You typically don't use RAID controllers with this at all. I mean, everything is controlled directly at just like the SAS, or I mean, it's just a direct.
Yes, yeah. So the question is, do you want to use RAID controllers at all? And the RAID controller is going to get in the way of reporting individual drives' health. You can use them, but you're taking away a big benefit in the file system driver itself that will actually do the MD5 sums of the blocks of each individual drive to help you discover which drive is going bad.
So let's say that you already have a server infrastructure that has these. Would you recommend replacing those RAID controllers with just like dumb
Would I recommend replacing RAID controllers? Well, I would recommend when you putting them into JBOD mode if you don't want to. You can make each a like a, what is that, RAID 0? Some controllers, there's not like an explicit JBOD mode. For each disk, you have to define what kind of volume it is, like to the RAID controller, and sometimes you can just say it's a single disk RAID 0, which is just a plain disk. So,
Gotcha.
Yeah. Next.
So, are the disk management and the file system part not exclusive of each other? In other words, couldn't you just run the ZFS file system on an existing RAID controller controlled array?
Yes, because what you would. So the question is, because I'm being recorded, is can you run ZFS on top of an existing RAID or block structure, some kind, like maybe a SCSI target, like a iSCSI target? That's another example of what you might see. Yeah, but you take away the ability for it to help you identify what drives are bad or performing poorly. So yeah, I mean, the base case is just it's just like installing on one single drive, and that's feasible and acceptable. Yes.
Are there any recommended like hot swappable controllers that you recommend as far as like that are like non-RAID controllers that can do hot swap?
I haven't. Since I don't build hot swap equipment, I don't have a great recommendation for a hot swap compatible controller. But for an affordable controller, there is a super micro 2-port SAS card that will drive 8 drives with a fan out. And often SAS cards do support hot swap just by default these days. So, yeah, it costs about $110.
Should really be anything
So.
that's supported by your operating system. ZFS wouldn't step on it.
Yeah. I guess it also depends on, like, does your RAID controller need to be told when to enumerate the drives again? Because, like with an LSI controller, you might have to use one of your mega control commands to like read the new serial number of the drive or something like that. So there are replace commands. If you have hot spares, there's replace commands too, which is generally more convenient. So you can assign a hot spare to a pool or hot spare to a mirror or a RAID Z. So you can insert new ones and make your mirrors 3 deep or N deep if you need to clone something and travel with it, for instance. That's another possibility. So.
What's the general status, sort of, from your view, of ZFS in production in the wild at the moment?
My view of, are people using ZFS on Linux in production? I believe so, and I think the biggest demonstration of that is Lawrence Livermore Labs. I believe that not only do they use ZFS, they use a couple of other cluster file systems too. But it's been very stable for me. I've recovered from bad drives, multiple bad drives even, because they were failing at different times, and I was able to swap them in. I think it's fine to use in production, but I wouldn't do that without, of course, practice. Just like you shouldn't set up an LVM volume on a server and you've never installed LVM before, because it is possible to install it incorrectly. You know, if you don't leave enough space for doing things like snapshots or whatever. I mean, with LVM you can really kill yourself if you install it badly once and throw it into production. So set up a staging machine, some kind of lab machine, get used to it, maybe use it as your workstation, of course. Yes, Steve.
So how do you even get started? Like what? So it's not included in the Linux kernel, right? It's like, are there distros that have it? How do you?
Okay, how do you get started with ZFS on Linux? And that's a great question. Depending on your distro, and there's really 2 general methods. The first is you can get it through, well, now with Ubuntu 16.04, it's an apt command away. You can also go to, there's packages. You usually compile through DKMS, the driver, and so when you reboot to a new kernel, you should have a plan for being able to get in as a user who can do DKMS to recompile that, because otherwise you won't see your pool. You have to maybe boot back to the previous kernel to get your pool back. So there's a little bit of planning there. So when you do upgrade your kernel, it's probably a DKMS install command away, though.
If you have an app that it does that automatically, though?
Well,
Most package management systems will do that automatically. They make hooks for DKMS.
yes, and I did not. Yes, DKMS does do some installs well automatically. Not all DKMS installs find the kernel that you intend to boot into, though. So that's, just be careful when you reboot it. What I do is I typically have like a non-root user that logs into like var temp or something as a home directory that's not in the pool, so that I can, you know, have a home directory and log in, recompile, reboot, that kind of stuff. Or you don't even have to reboot. Rebooting is a safety check in this case, because you could just do mod probe ZFS and load it. Okay, who is next?
I know this is about ZFS, but did you discuss, I missed like half of the picture. Did you talk about ButterFS at all, or? Like
I did not talk about ButterFS. ButterFS is interesting because it's one of the only other file systems currently that does checksumming on its data, in my mind, and it also supports snapshots and flexible layout. There's a lot more people maintaining ZFS than ButterFS. ZFS is been in production for decades now, and I don't know what Facebook concluded with its ButterFS rollout, but I know that they've been adding. I presume they've been adding stuff to ButterFS. I'm not a big fan of ButterFS, but I am not an expert in it either, so I would not really offer my opinion. Yes?
You mentioned in the talk that you prefer using the serial numbers of the drives when they, you know, over the drive letters. Basically.
Yes.
And so typically if you had like a drive fail, you should be able to just pull it out and pop in a new one, and like dev SDC is still dev SDC. Is there a procedure that, because you're using your serial numbers, that you have to like pull that out of the pool and then add the new one in?
Okay, so the question is, why doesn't pulling out a drive and putting in a new one work, and why do I use serial numbers? UDEV is what creates most of your devices in DevTree, and so it's reading a bunch of information from the devices to name them. The problem is that when you put in a blank drive, it needs to figure out where to put it, and it doesn't necessarily know the cable ordering. So if you plug it back in, it might assign it a new drive letter, because it doesn't know, since it has a different serial number, if the one with the old serial number is going to show up again, because you could be doing two different operations. So it doesn't really know the port. It knows the address that the port's on, but it can tell the difference between which drive. The drive label is going to be different. These are GPT partitioned drives. It's going to want to add, when UDEV sees the disk, it's going to want to add entries in, you know, /dev/disk/ by label, by ID, by other things, by path, if you have a multipath controller. So UDEV is why I don't use the SDA, SDB, SDC numbering, because I've seen it switch on me across reboots. This is also one of the first bits of advice on the ZFS on Linux page too.
So when you have a drive failure, do you issue a command to drop it from the pool?
When a drive fails, I issue a remove command or a replace command. When you have a mirror, you can remove a drive from a mirror. When you have a RAID, like a RAID 1 or RAID 2, RAID Z1, RAID Z2, which is RAID 5 or RAID 6, you do a replace. The remove command won't actually work for that. So the best way to do it is to put the new drive in and do a replace, and it'll rewrite the drive with what was on the previous drive, what it can read if it can, and then it'll just take that old drive out of the pool. Yes?
So going off of that, then, say you, being the noob that you were,
Yeah.
decided to use SDA, STB, STC, all that.
Okay.
Serial numbers. Is there a command to quickly switch it?
Okay, so say you do a ZFS install and you use the dev SDA numbering or lettering, however you say, and you want to change it. No, there's not an easy way. What you end up doing is you end up removing all that stuff and re-adding it. So what you could do is, if you have even one spare disk, you can do a replace in like a RAID Z2 and replace it with the serial number of the other disk, and then do that over and over. Do the shuffle and replace each disk to a serial number version. Yes?
So just to iterate on your question, you can export the whole pool
Yes.
and then re-import by disk ID from that point. It'll just still read the metadata on the disks.
Oh, that is also so the
Yeah, so like when you reboot, it'll export it
uh-huh.
on Ubuntu.
Yeah.
And then re-import it through init scripts when you reboot.
Mm-hmm.
And you can just do that manually just by zpool export and re-import,
Yes.
re-import it by disk ID from that point.
Okay, that's useful. I have not tried that. Okay. Okay, so for the recording, it is possible to export a ZFS volume and then re-import it with a flag that tells it to import it by serial number instead of the UDEV naming. These are great questions, and I often learn stuff by getting the questions, so this is good for me too. Yes?
I had a couple comments. You can even like add a RAID controller and renumber all your drives and that sort of thing. So that's really good to use by ID or by serial. I worked for a company that produced a ZFS appliance on Linux, and we did by ID in the product for all the same reasons. And then you mentioned on the compression, you can actually select the compression that you want per file system on ZFS. So you could have the really fast, get better performance on your spinning disk production areas, but have a backup file system where you wanted the most compression, and you could use GZ9 if you don't want to ever have it finished, but
Yeah.
you can use different algorithms if you have data that compresses better with different algorithms, etc.
Yeah, yeah. So I'll repeat the last point, and that was that you can change. You can also change the file system compression. Any new blocks written will be written with compression because that information is stored in the metadata of each block. So you can assign different compression levels to each file system. And it's perfectly valid not to have any compression on a file system too. You know, like if you have a bunch of MP3s, why compress that? Next question. Does anyone have any interesting hopes for building large store all the things equipment? Have you guys ever read R Data Hoarder on Reddit? Yeah, go check out R Data Hoarder on Reddit. That's a good read. Yeah, but it talks about not just ZFS, but it also talks about anyone who's building storage. Also, the Reddit home networking subreddit can sometimes discuss storage too, but you get some mighty nerdy comments in the Data Hoarder subreddit. It's good stuff. There's also a ZFS subreddit too. It's a bit more dry. You don't get so many good stories as you get in. Yeah. Yes. Next question.
What are the legal issues?
Legal issues of ZFS and licensing.
Yeah. That you should be concerned about.
Yeah. Well, it's okay. ZFS is licensed under CDDL, which is the Sun's community license stuff. Technically, it's incompatible with GPL because you should only redistribute Well, because it becomes, when you do a binding, even a runtime binding, it adopts the, there's a thing where you adopt the license of the license you installed latest for that. It's complicated, because some people think that like the notion of is derived is different. So is the Linux kernel derived from GPL code? Of course it is. When you add a non-free module to it, suddenly it's derived and it has a different legal status. It's a new deliverable. And that's kind of the root of the conflict there, is that yeah. And many people are saying it should not be distributed with Ubuntu, because that is the problem. If you just pull it down normally, there's no problem. The problem is redistributing them in binary form together. So, and I seem to recall someone did a review of 1604. Maybe this was on Linux Action Show, where ZFS isn't actually installed automatically. You still have to issue all of your ZFS commands, and there's no facility for ZFS on root. So it is possible to install Linux on ZFS as your root file system, and this is a common feature in FreeBSD now. But that is Ubuntu, are shipping something where they will deliver the updates via apt, but it's still essentially going to be using DKMS, or you could do a new kernel, however you want to do it. But it's really nothing special. It's a lot of hot air, in my opinion. Yes.
If I understand that right, then what you're basically saying about the licensing issues is, like, if my office went with ZFS on Linux, we're in no way can we be in hot water at all. The only people that could be in trouble would be the distributions that put ZFS with Linux.
Correct. Yes. Yeah. So if you were to, it might be interesting. There might be, if you're using a product with ZFS on it in house and you put it there as a third-party administration thing, there's no problem with that. There's no police that are going to knock down your door for that. But if you were to sell a system with ZFS in it, ZFS on Linux, I don't know what that licensing scenario looks like. So, do you become a distribution? Do you become a distributor? Is anyone going to care? So, I don't think anyone's going to care, but then I'm pretty lackadaisical about it. Yes?
Is there any, for Ubuntu, is there any incentive for why they would want to put ZFS built into their own operating system instead of just having you pull it in if and when you want to use it? It seems just like a complicated.
Is there incentive for Ubuntu to ship with the ZFS drivers? ZFS is super popular among storage designers, and Ubuntu is super popular in the cloud. Like most of Azure, like 60% is Ubuntu installs. They're hoping to reach a market of people who want to have a quick install with the minimum level of administration to get ZFS. They are clearly fans of ZFS, and in their mind, they found a lawyer that says, don't sweat it. Okay, you had a question, yes.
Yeah, do you have any tips for high levels of contention with volume creation leading to lots of failed volumes?
Okay, do I have issues with high levels of rapidly creating volumes? I have not created a rapid volume creation environment, so I could see like doing that with doing imports maybe, or
this is
like
Docker on ZFS.
Oh, okay. So in a case where you have Docker on ZFS and you have, say, hundreds of customers creating Dockers for their applications, and you create a ZFS volume for them on demand, can it go too fast, and can it lose metadata, lose consistency?
It doesn't lose metadata, it just locks up and says dataset busy.
I have seen dataset busy, and that is not from creating, but that was from dealing with 70,000 snapshots. That's so, like, if you have 2 ZFS or ZPool commands going that need to touch whatever the big lock is in the driver, it'll bounce you back. So that's, yeah.
Work around that, like tuning tips.
I think if you wanted to work around that, you probably want to plan multiple pools, because I suspect there's going to be 1 lock per pool. Yeah? You guys still awake? Questions? Yeah.
So I was just kind of curious about the state of ZFS amongst the different vendors. So we've got, you know, the Sun Oracle ZFS. We've got OpenZFS. Now, is BSD using OpenZFS as
Okay.
Linux, or is there kind of 2 forks right now? And how's the feature set and RIF, that kind of deal?
The state of ZFS on various vendors is actually very simple. ZFS had stopped development of ZFS by Sun essentially stopped during the Oracle purchase of Sun. And OpenZFS, the organization, was created. And briefly, for a few years, there were individual ports to operating systems of ZFS. That has all been coalesced in the OpenZFS project now. So when someone adds a feature, say FreeBSD adds features to ZFS quite rapidly, for instance, they add it to their tree, and then they help port it to the ZFS code base, and then everyone else gets it. So there might be some features that are turned off by flag because there's no base operating level system for the operation. So there might not be features available on some operating systems, but in all the basic features and all that, they all show up in OpenZFS, and everyone gets them. Yeah. That's a great question. Yes, because I have seen that. I've been using this long enough to see that change happen. That's very interesting. It's one of those open source success stories, and how you can actually unfork something. Yeah. Yeah, next.
So I've gathered that ZFS is a fairly old system.
Yes, some would call it
what's
mature.
What's the incentive, I guess, to present it here then, if it's been around for as long as it has?
Because it is not the new hotness, actually, is because in terms of data set management, having a more flexible way to create and transfer snapshots is extremely useful. Yeah. And it's, in my mind, a lot easier to use than LVM. That's why people like it so much. LVM is been a default in Linux distros for decades. It's not as flexible as ZFS.
I'd add that file systems are kind of like wine. They need to age a little bit. You do not want to use that new hotness.
Yeah, people have been burned by ButterFS. Yeah, you listen to a couple of podcasts and people gripe about ButterFS. Like the first year it was out, people were griping about it a lot.
Even recently, there was a kernel issue, and you upgraded to the latest kernel and reboot, and then your ButterFS is unmountable. And that was in a 4 dot something kernel. Maybe it was late 3 kernel, but
okay. But still, recent
like
enough
6-8
to be
months.
Worrying. Yeah. But this stuff is hard. So I would forgive a guy who would create a file system that didn't boot once in a while, because it's not simple. But yeah, you kind of want a file system that has had most of those things all worked out already. And honestly, there are bugs in ZFS. Well, not just that no software doesn't have bugs, but you listen to enough of these podcasts where they talk about ZFS, they get interviews on people who are working on ZFS, and they say, oh yeah, we know about that bug. And so there are bugs out there. But if, you know, a lot of that is, how do I migrate something from a very old version of FreeBSD to a very new version of FreeBSD, and why is it taking so long? And it's stuff that hopefully we won't see on Linux unless you've been using it 10 years and are switching very old ZFSs to very new ZFSs. I have no idea where the bugs are going to show up, but in general, very stable. Yeah, you have a question. You have a question. Are we done? Okay. Thanks for letting me jabber.